In addition to melting glaciers, significant thermal anomalies have also been observed in the ocean. Where does the ocean get heated the most? As you can see on the map, of the averaged model of ocean water heating, the ocean water gets heated the most in the area of the Greenland tectonic zone, that is, in the area of the ascending magma chamber. But what is another key process occurring in this part of the ocean? It is in this area that an extremely abnormal process has started in recent decades, the shutdown of the Gulf Stream. Incompetent journalists write that the shutdown of Gulf Stream is caused by Greenland's meltwater. However, according to the calculations of oceanographers, the Gulf Stream is 20 times stronger than the oncoming cold stream of meltwater. This flow of cold water can be compared to a spit against a waterfall. So what kind of impact can we talk about? In May 2010, there was a short-term shutdown of the Gulf Stream. Why? Geologist James Camis has deducted a chain of correlations on how the Gulf Stream shutdown is linked to changes in the planet's interior. In 2009, the magma ascent caused a series of earthquakes in the vicinity of Iceland, which followed by the well-known eruption of the Eyjafjallajökull volcano in March 2010. And as early as May 2010, a huge mass of hot water surfaced across the tectonic zone along the faults and stopped the movement of the Gulf Stream. You can see this process on the screen right now. In other words, the shutdown of the Gulf Stream now occurs in pulsating stages as a result of the release of enormous heat caused by the ascent of magmatic chambers beneath Greenland. Given that magma chamber beneath Greenland is becoming more active, we're getting closer to the point when the Gulf Stream will stop completely. The last time, what's important, the Gulf Stream stopped was 12,000 years ago. Remember that figure, 12,000 years. You've heard about it already. And what is important, oceanologists note that such phenomena of water heating occurs not only in the area of Greenland, but across the entire world's ocean. So let's take a look at what is going on.
The ocean is the source of life for the entire planet, and for us, humans. But it ceases to be the source of life. It is about to become the source of our death. Just think about it. Ocean warming has increased by 450% in just 30 years. According to scientific estimations, for the ocean to heat up at today's rate, it would take as much energy as would be released if 7 atomic bombs dropped on Hiroshima would explode every second for a year. The direst fact is that the ocean is heating not only on the surface, but also at depth. A team of US researchers has found that the average depths of the ocean warmed 15 times faster over the past 60 years than they had been warming over the previous 10,000 years. And this progression is accelerating every year. At the moment, science has no explanation where this amount of heat comes from. The only theories being considered are that the oceans are warming from the sun and from human emissions of the greenhouse gas CO2. But they can only explain heating of the upper layers of the ocean to a depth of up to 200 meters, because sun rays do not penetrate deeper. The water can be maximally heated by the sun up to 700 meters as a result of agitation. How can we explain the numerous facts of warming of the deep ocean layers? Think about it. How much energy does it take to heat such a volume of water as the world's oceans? We already see examples of such anomalous heating everywhere, not only on the bottom, but also on the surface. At the end of 2013, a huge area of unusually warm ocean water, about 1/3 the size of the United States, formed in the Gulf of Alaska, and it began to spread. The water temperature in many places exceeded the norm by 5 to 6 degrees Celsius. National Geographic dubbed it the blob that cooked the Pacific. Nick Bond, state climatologist for Washington, named this phenomenon the blob. The appearance of such anomalies began to suddenly become more frequent. There is something common that unites the places of formation of all these blobs. These are geologically active regions with a young, thin crust, with active underwater volcanoes, cracks, and deep crustal fractures. These are places of the most active output of hot and fluid magma. The ocean is called the kitchen of weather. The warming of its waters already enhances catastrophic typhoons and hurricanes, which annually claim thousands of human lives. The unprecedented heating of the ocean suggests that the ocean is already exhausting its ability to contain the energy trying to escape from the bowels of the earth. And when magma reaches the denser and thicker rocks of the continental crust, which on average is 2 to 3 times thicker than the oceanic crust, then the processes of cascading eruptions of land volcanoes will begin, and it will be too late to stop this process or to seek salvation.
As we can see, the ocean is warming at the seafloor, not only in the Weddell Sea, but also all over the world. Even the mid-depth are warming, while huge volumes of heated water, the so-called blobs, are rising to the surface. Note that such huge blobs of hot water have been appearing more and more frequently since 1995. Look at the bottom right graph. Obviously, no human emissions are capable of heating up the ocean as much as 5 to 7 degrees Celsius over such a short period of time. All the more so, only in local areas. In light of this, the theory that anthropogenic emissions warm the oceans sounds ridiculous.
As we have already understood, it is heated from underneath by ascending magma. How exactly does this happen? Now you're going to hear something unique about one of its heating mechanisms. Please turn your attention to the screen.
Think about it. How much energy does it take to heat such a volume of water as the world's oceans? That would require a colossal heat source. The energy required to heat it equals the energy of all the nuclear reserves on Earth multiplied by 3. What could heat the ocean from below like a pot on a burner so significantly? Let's dive to the ocean floor and see what sources of powerful heat are out there. As we plunge, we discover giant mountains at the bottom. Volcanoes. 75% of all Earth eruptions occur from underwater volcanoes. Previously, it was considered that underwater eruptions occur with a gradual outpouring of lava, while explosive eruptions are impossible because of the pressure of the water column. And thus, it was assumed that underwater volcanoes could not heat the water column. The outflowing lava would freeze almost immediately. However, recent research is changing our understanding of the mechanism of underwater eruptions. What is the mechanism of such an eruption? The pressure of the magma ranges from 10 to 30,000 bars, but the pressure of the water column in the deepest parts of the ocean is only 1,000 bars. And as soon as there is an abrupt burst of magma, the water boils up and the H2O molecules decompose into hydrogen and oxygen. This creates a gas-water cavity like a bubble with an internal pressure of hundreds or thousands of bars. And this bubble neutralizes the pressure of the water column. This is a complex physical and chemical process that can be compared to the flight of a hypersonic airplane at maximum speeds. The plasma ejected in front of its prow neutralizes the molecular resistance of the air, making the plane fly almost as if it were weightless. The combustion of oxygen and hydrogen creates the same effect in the path of the magma, resulting in explosive eruptions. The existence of such explosive eruptions is confirmed by the discovery of researchers from Leeds. They studied kilometers of fields of tephra, meaning settled volcanic ash, at the bottom of the Pacific Ocean near the Juan de Fuca Plate. A mathematical model showed that such plumes could only be formed by a massive explosive eruption. In addition to the spread of heat, volcanoes during explosions burst out of hydrotherms, hot jets of water. Studies have shown that the volumes of ejected boiling water can be tremendous, about 40 million Olympic swimming pools, and they are quickly formed during eruptions. The contribution of explosive eruptions to ocean heating is confirmed by Bernd Zemanowski from Julius Maximilian University in Bavaria. With submarine lava eruptions, the thermal equilibrium currents in the oceans are disrupted locally or even globally. However, given the size of the ocean, the energy of even such strong underwater eruptions is not enough to heat it up. Since active volcanoes are not located everywhere, and their eruptions are occasional, why then has the ocean heated up so much over the past 30 years?
The really scary thing is that volcanoes are not located all over the seafloor. However, the heating is already occurring all over the ocean. This suggests that not only underwater volcanoes do the heating, but the magma itself has started penetrating the ocean seafloor globally and heating up the ocean. And I ask you to pay special attention to another important piece of information from this video. Contrary to conventional belief, powerful, explosive eruptions are occurring at the ocean floor. Take a note of the fact that magma can suddenly penetrate the seafloor and form a bubble that can negate the pressure of the water column, and thus conditions are created for a powerful explosion at the ocean floor. This is a very important point, and further you will realize why.